This is the trick question where a simpler diagram would be something like this. And you know that these three resistors are parallel to each other, 60 ohms, 30 ohm, and 30 ohm. Okay, so how do you identify that? Look at this point and this point. There is nothing in between, it's a wire. So these points are as good as one point. Okay, so we can call that point as A. So this is A, point A, which is over here. Again, look at these points. So that are also as good as the same point, that is point B. So that means for all the three resistors, they are both the terminals have common to each other. So like this is terminal 1, terminal 2. Okay, so all their terminal 1s are connected together and all their terminal 2s are connected together. So therefore, the resultant will be 1 by 60, 1 by 30, 1 by 30. So the LCM is 60. This is 1s are 2 and 2. So R will be 60 upon 5, and that will be 12 ohms. Question is to find the resistance between point A and point B. We take current I entering A, that will get divided into I1 and I2. The current I1 flows straight through 12 ohm resistor and reaches point B. For I2, the current reaches here, and that current has to then branch into 2. So if that current is branching out into, let us say, I3 and I4, so I3 goes straight and I4 goes through these two resistors. So same current is flowing through this 6 and this 6. That means they are in series. So I'm going to call that 6 plus 6, that is 12 ohms. Okay, so I have to redraw this diagram now. So to see what changes have taken place. So this is point A, this is point B. Okay, so this is what we have over here is 6 ohms. Then we have a 12 ohm resistor. And now these 6 have been resolved as another 12 ohms. Okay, so this is very clear now that these two are parallel. So we get 1 upon R2 as 1 by 12 and 1 by 12. So therefore R2 will be 12 upon 2. R2 will be 6 ohms. Okay, so what does that make? So I will just copy this and edit that diagram here. So we have these two resistors together giving you 6 ohms. Okay, so students, what did I tell you? This is I1, this is I2. So that means I2 is now flowing through these two resistors. So this will be 6 plus 6, and that will be 12 ohm. So what will be the final resistance? Final resistance will be 1 by 12, which is 12. So that will be 1 by 12, 1 by 12, 1 plus 1 upon 12, 2 upon 12, R will be 12 upon 2, and that will be 6 ohm. So the final resistance is 6 ohm. 12 and 3 are in series, 5 and 10 are in series, 10 and 20 are in series. So therefore, you have 12 plus 3, that is 15 ohms. This is 15 ohms, and this will be 30 ohm. So the resultant will be 1 by 15, 1 by 15, and 1 by 30. LCM is 30. So this will be 5 by 30, and you get 6 ohm as your answer. This resistor combination is same as what we have done a few sums back. In that question, I told you that these three are in parallel. So now in addition to that, we have two more resistors connected to it in series. So what we will do is, we'll say 1 upon R1 as 1 upon 24. This is 12 and this is 12. So therefore the LCM is 24, 1, 2 and 2. So that will be R1 will be equal to 24 upon 5, and this will be 4.8 ohms. So instead of this whole combination, we will have, this is 30. So this is point A, which is 30, point B, which is 30, and this whole give us 2.8. So therefore the resultant resistance will be, yes, so that will be 64.8 ohm will be the final answer. There is a wire given, and the resistance of this wire is equal to 20 ohms. Now this wire is cut into 4 equal parts. So each part will have resistance 20 by 4
ohms.
5 ohms. Now these parts are connected parallel to each other. So there will be one. So this is point A, point B, and this will be 5, 5, 5, and 5. So the effective resistance is 1 upon 5. The resistance will be 5 by 4, which will be 1.25 ohms. Remember this, whenever two resistors are connected in parallel, the resultant will be smaller than the least resistance. When there are two resistors or more resistors connected in parallel, the resultant resistance of the combination will be smaller than the least resistance in that combination. Let the two resistors be R1 and R2. So therefore, you have R1 plus R2 as 9 ohm plus 1 upon R2 as 1 upon 2 ohm, because okay, I'm taking an LCM. But we have R1 plus R2. So that will be 9 upon R1, R2 is 1 by 2. So therefore we get R1 into R2 is 9 to the 18 ohms. So we have these two resistors, that is R1 plus R2 as 9 and R1 into R2 as 18. So there are two ways of solving, okay, with algebra. So let me show you one way. R1 minus R2, the whole squared, is R1 plus R2 the whole squared minus 4 R1 R2. Okay, because you know that A minus B the whole square is A plus B the whole square minus 4AB. So here you have R1 plus R2 as 9 squared, and this is 18. So this is 81 and this is 72. So that will be 9. And therefore R1 minus R2 is 3. Now you can solve it simultaneously. You have R1 plus R2 as 9 and R1 minus R2 as 3. When you add them, you get 2R1 as 12 and you get R1 as 6 ohm. So therefore, 6 plus R2 is 9. So R2 is 3 ohm. The other way is you have R1 and R2 as 18. So we can write R2 as 18 upon R1. And therefore, the other equation is this. So we have R1 plus R2 as 9. And R1 is R1 plus 18 upon R1 is equal to 9. So on solving this, what do we get? The LCM will give you R1 squared upon 18, the whole upon R1 is 9. So we get R1 squared plus 18 is 9R1. R1 squared minus 9R1 plus 18 is 0. Okay, the product is 18 and the sum is minus 9. So the numbers are minus 6 and minus 3. So you get R1 minus 6, R1 minus 3 equal to 0. Therefore, you get R1 as 6 or 3. So the answer will be 6 ohms or and 3 ohms. Okay, so these are the two resistors which when added give you a resistance of 9 ohms and which when connected in parallel give a resistance of 2 ohms. So even if there are two resistors, this is quite an interesting question. So this is very much in syllabus, can be asked, okay, where again working need to be done. Either you do it this way, where you end up solving a quadratic, you have to factorize this, or you can do it this way, where you're using the formulas of expansion, and then you are using your knowledge of simultaneous equations. So here there are three set of diagrams. So this is the first diagram. and they have given the equivalent resistance of this is to be 5.6, and we have to calculate the value of X. Okay, so if you look at that diagram, I'll just redraw it. So in this diagram, this is point A and this is point B. The resultant resistance is 5.6 ohm, where this is 2 ohms. Okay, so obviously, if you replace this by a single resistor, it will look something like this. So this is 2 ohms, and this is some R1 ohm, and that is giving you 5.6. So how should I write it? I will write this as 5.6 is 2 plus R1. So R1 is 5.6 minus 2, and R1 will be 3.6 ohm. But what is R1? R1 is resultant of these two in parallel. So therefore, 1 upon R1 is 1 upon X plus 1 upon 6. So I have 1 upon 3.6 equal to 1 by X and 1 by 6. So which I can write it as 10 upon 36 minus 1 upon 6. So that is 36. And here, this is 6. So X will be equal to 36 by 4. The value of X, I'm getting it as 9 ohms. Okay, so again, a simple question with only 3 resistors. But you need to understand the, which one are in series and which are in parallel. Okay, we move to the second part now. For the second part, the total resistance is 12. And here we have 3 resistors. Again, the combination is similar to what it was in the previous question. Only thing is that all these resistors are X, X, and X. Okay, this is point A and this is point B. So when these two are in parallel to each other, so let us say that their effective resistance is R1. So that is 1 by X and 1 by X. So we get the LCM as X, and this is 1 plus 1. That is 2 by X. So what we have over here is R1 as X by 2. Okay, so I can redraw this diagram as this is A, this is B, this is X, and this is X by 2. So now you can see that they are in series, and their resultant is 12. So 12 will be equal to X plus X by 2, which will be 2X plus X upon 2, and that we get as 12 upon 2, and this is 3X. So 24 upon 3 is X, and X will be 8 ohm. So that's the answer to the 8th question. In this question, we have these two in series and these two in series, and the resultant of that is parallel to each other. So we can have 5X and X, and the other one is 8 and 4. So instead of this 8 and 4, I can call this as 12 ohm. So we can see that R1 is 8 plus 4. R1 is 12 ohm. In a similar manner, I can call R2 as 5 plus X. So I can replace this over here by some R2. Now the resultant of those is 4 ohms. So therefore what we get is 1 by 4 equal to 1 by R2 plus 1 by 12. So we have 1 by 4 minus 1 by 12 as 1 upon R2. So this will be 3 za, this will be 1 za. So that will be 3 minus 1, that is 2, you get 6. So therefore we have R2 as 6 ohm. So 6 is equal to 5 plus X. X will be equal to 1 ohm. So the answer to this X is 1 ohm.